Okay, let's go through the second exam review, and let's see how it goes from here. First question, it says to solve the system of equations by graphing. So first I need a pencil. So I need to be able to draw here. And so we have two equations, 4x minus y equals 2 and x plus 2y is equal to 5. What I would like to do at first is I would like to write both of these equations as y equals mx plus b, because if we write it in this form, then this will be the slope and b will be the y-intercept. So let's see if I can make this a little bit thinner. All right, so here we have 4x minus y is equal to 2. So we could say add y to both sides. Get 4x is equal to y plus 2. I'm going to move this 2 out of the way so that the variable y is by itself. So we have 4x minus 2 is equal to y, or just y is equal to 4x minus 2. This would be the slope. And negative 2 will be the y-intercept. So what I could do is, see if I can make this a little bit thicker now. Just a slightly, okay, I think that would probably didn't do much there, but in any case, so we go to the y-axis and we look for negative 2. I'm going to put a point here. And then I'm going to use the slope, which happens to be 4, or in fraction form, 4 over 1. So what I'll do is I'll go up 4 units. So I don't really like the scale of this too much, but this will be 1, 2, 3, 4 over 1. And then from 2 to 6 over 1. Wow, this couldn't be any more painful to the eye. And so therefore we can connect these 3 points using a straight line. All right, so something that looks like this. All right, that was kind of painful to the eye, but let's go ahead and take care of the second line. So let me use a different color. Try to use this color here. And the other line is x plus 2y is equal to 5. So we want to get y by itself. So in this case, I'm going to take away the x. And we have 2y is equal to negative x plus 5 divided by 2, divide by 2, divide by 2, so that the variable y is by itself. And we get y is equal to negative 1/2 x plus 5 over 2. Well, this couldn't be any worse than that, okay? Because I cannot really plot 2.5 as my y-intercept of 0.5. Oh, I guess I could, but I guess I could. But I don't know if I really want to do it like that. So let's see, maybe we can find a different way to do this. Okay, I'm going to try a different way to do this, okay? So we have x plus 2y is equal to 5. Now, I'm going to use the fact that I know the slope. This will be the slope, but I need a good starting point. And it turns out that the x-intercept, if we just delete the y term, we get that x is equal to 5. So that's much better than trying to do 2.5 as the y-intercept. Okay, so in this particular case, I use the x-intercept. And now I can use the slope, which the negative means count down 1 unit. and then go to the right 2 units. That's because of that negative. So down 1, okay, over 2. Once again, kind of painful to the eye. Down 2 over 1. Okay. And let's see if I can trade my steps back. So that will be up 1 over 2. So this will put it here. Up 1 over 2. Okay. And the reason why I did that is because I was looking for an intersection point. So this is actually pretty difficult to do now. All right. So see if we can get. All right. So what I'm noticing, let's see. We could use a different color for a solution now. What we're looking for is a point of intersection. A point of intersection. Since both of these lines intersect at the point 1, 2, that will be the solution. So the solution is the point of intersection. And in this case, that happens to be the point 1, 2. So this example has a unique solution, and that solution happens to be 1, 2. Don't forget to put the parentheses, otherwise you'll get it wrong. All right, so let's go ahead and move on out of here. Before I do that, let's just have a conversation as to when we will have a situation. Let's go through three scenarios. This will be the x-axis. That will be the y-axis. If we have line 1 that intersects line 2, this point right here, x comma y, will be the unique solution. An example of a system with no solution, it's an example where we have one line here and another line that is parallel, that will be no solution. The reason for that is there will be no point of intersection. Here, if we have the x and y axes, and here we have line 1, but right on top of that line, we also have line 2 right on top of it. In that particular situation, we have a system with an infinite number of solutions. A system with an infinite number of solutions. Why infinite? It will be infinite because these two lines will intersect at many, many points. So it will have an infinite number of intersections. Alrighty then, let's go ahead and move on to question number 2. It says solve the system by the substitution method. And so in this particular system, they're giving us an equation that says y is equal to this expression in terms of x. So what can we do? We can take the first equation and make a substitution for y. In this case is 3x. Try to erase that, make it look better. Here we have 3x plus 6 is equal to 8. Notice that this was y was substituted for this expression here. So using our algebra skills, we go ahead and distribute. So we get 9x plus 18 is equal to 8. Combine like terms, here we get 10x's plus 18 is equal to 8. We need to isolate the variable x, so minus 18 on both sides. We get 10x is equal to That will be negative 10. And in this case, we have to divide by 10. X is therefore equal to negative 1. Now that we know that X is equal to negative 1, we can say, well, there is an equation that tells us how to find Y. And Y is therefore equal to 3 times X. X is equal to negative 1 plus 6. Y is therefore equal to negative 3 plus 6. Y is equal to positive 3. Okay. Just make sure you follow what my MATLAB is asking you for input. So make sure that you input that correctly into your exam. Solve the system of equations below by using the elimination by addition. The idea here is this. Here we have two equations. 2m minus n is equal to 5. And here we have m minus 2n is equal to negative 8. And if we add these two equations, we get 3m minus 3n is equal to negative 3. Notice that as we added these two equations, we still have an equation in terms of m and n. That doesn't help us out. We would like to add the two equations so that the resulting equation only has one of those variables, either an m or an n. So this is not going to help us out. But what can we do instead? We could probably say that take equation 2 and multiply it. So this will be equation 1. This will be equation 2. Take equation 2 and multiply by negative 2. Equation 1 remains exactly the way it is. But now equation 2 gets multiplied by negative 2. Well, let's see what we have here. 2m minus n is equal to 5. Negative 2m plus 4n is equal to, okay, so what I should have done here is, let me try to do this. Erase. Okay, let me put the n back, and let me actually put there. That's better. Okay, so that we don't forget to multiply that negative 8 with that negative 2, therefore it comes up to positive 16. But when we add now, notice that the m variables will go away. We have 3n is equal to 21, and after dividing by 3, we get that n is equal to 7. Well, after we know that n is equal to 7, then we can go ahead and find the value of m. Okay, I was trying to switch colors there, but this thing keeps popping up here. Okay, that's better. So let's go ahead and find, in this case, m. So let's use 2m minus n. So I'm using the first equation just because I want to use the first equation, but you're welcome to use equation 2. N is equal to 7. So to get m by itself, we add 7. We add 7. 2m is equal to 12. After dividing by 2, we have that m is equal to 6. All right, let's go ahead and take care of an application problem. And so let's see what we have. Bill Lute's dog is on a strict diet. The dog is to receive among other nutrients, 36 grams of protein and 5.6 grams of carbohydrates. Bill has only two two food mixes available of the following compositions. Mix A has 30% protein, mix B has 40% protein, while mix A has 8% carbohydrate and mix B has 4% carbohydrate. It says how many grams of each mix should be used to obtain the right diet for his dog. So at the end, we need 36 grams of protein, 36 grams of protein, and we need 5.6 grams of carbohydrate. Now, with these numbers, we can set up an equation. So we can say, let x1 represent the number of grams of mix A, the number of grams of mix A, and we're going to let the second variable be the number of grams of mix B. So therefore, we can write the following equation. 0.30 x1 plus 0.40 times x2 is equal to 36. And then we have 0.08 x1 plus 0.04 x2 is equal to 5.6. All right, so this is the system that we have to solve. And so in this particular case, one thing that we could do is if we don't want to use these decimals, then we can go ahead and get rid of them by multiplying. This is just an option here. We can get rid of those decimals by multiplying both equations by 100. And that will get rid of the decimal. So let's see what that looks like. Okay, so we have now, in this case, we have now 30 x1 plus 40 x2 is equal to 3600. And here we have 8 times x1 plus 4 times x2 is equal to 560. Now we can go ahead and I'm going to use the elimination by addition method here. So I would like to get rid of the variable x2. And in order to do that, multiply the second equation by negative 10. So let's see, we have, I know we're taking a little bit of the other questions room, so but that's okay. 30x1 plus 40x2 is equal to 3600. Here we have negative 80x1 plus, minus 40x2 is equal to negative 5,600. And after combining these two equations, the second variables will disappear. And so we got negative 50x is equal to negative 2,000. To get, x1, right? x1. To get the x1 by itself, divide by negative 50, and x1 is equal to positive 40. Now we need to find the value of x2. And so therefore, I think I want to use this equation here. It seems like the easier equation to use, but you can use any of the equations that you have. And so therefore, let me write that a little better. That looks a little funky. That's equal to, what do we have here? 560. So we know that x1 is equal to 40, so 8 times 40 plus 4 times the second variable is equal to 560. That will be 320 plus 4 times x2 is equal to 560. Take away 320. We get that 4 times x2 is equal to 240. After dividing by 4, x2 is equal to 60. So therefore, in order for Bill to mix his dog's food correctly, he will need 40 grams of the mix A and 60 grams of mix B. All right, let's see if we can squeeze example 5 here. It says find the size. Maybe we could use a different color. Maybe that would be better. It says find the size of the matrix and determine if it is a squared column or row matrix. So in this case, it has 1, 2 rows, and 1 column. Therefore, the size is 2 by 1. And this is a column matrix. All right, that's the end of that story. For example, 6, it says write the coefficient matrix and the augmented matrix. So therefore, you should have 2 answers here. The coefficient matrix will be the matrix with the coefficients of the first variable. And that's it. And then the augmented matrix will be the coefficient matrix augmented with the column matrix 1, 9. Okay, so I'm expecting, I believe that my MATLAB will expect two solutions there. All right, moving on. Number 7, it says to perform some row operations on the following augmented matrix. And here, what that says is swap row 1 with row 2. So therefore, now row 2, so this is row 1. This is row 2. So we have 4, -5, -8, 1, -6, 3. On number 8, it says to perform another row operation, which says multiply row 2 by 7, add it to row 1, and that becomes our new row 1. So what that means is let's take everything in row 2, multiply by 7. That will be equal to, oh, this is not a 1, this is just a vertical bar, okay? So here we have 28. Let me see if I can write that up here because we won't have to rewrite it again. We have 7 times 4 is 28. 7 times negative 6 is negative 42. 7 times negative 8, that's negative 56. And it says to add it with row 1, which is 1, negative 3, 2. So therefore, the new row 1 will then be equal to 29, negative 45, negative 54. So we have 29, negative 45, negative 54, 4, negative 6, negative 8. All right, let's move on. Number 9, it says, the matrix below is the final matrix form for a system of 2 linear equations with the variables x1 and x2. Write the solution of the system. Okay, so if that's the case, then the first variable will be equal to negative 7, and the second variable will be equal to 4. End of story. Okay. Number 10. It says to solve the system using Gauss-Jordan elimination. So maybe I should erase this because I'm going to need a little bit more room here. So what we're saying here is, back to this example, let's do that. X1 is equal to negative 7 and x2 is equal to 4. In number 10, we want to use Gauss-Jordan elimination. So we're going to need an augmented matrix, and here's the coefficient matrix. We have 1, 7, negative 16, and here's the vertical bar, and then we augment the column matrix with those entries. If we're going to complete this example using the Gauss-Jordan elimination, then the final answer must be something of this form: 1, 0, 0, 0, 1, 0, 0, 0, 1, where we have M and P. And maybe we'll get this, we'll get a unique solution, where in this case, if we're able to do this, then x1 will be equal to the number M, x2 will be equal to the number N, and all right, so probably take 3 on this particular example just to get it right. All right, we're just gonna write out the steps and what we did to get to arrive to a final answer here. Okay, so that way we know that we worked it out by hand. So here we go. We're going to take row 1 and we're going to swap it with row 3. Then we're going to take negative row 1, add it to row 2, and that gives us our new row 2. Then I went ahead and took row 2, multiplied it by 1/6, that is our new row 2. And so then I took 6 times R2, row 2, plus added to row 3. That became our new row 3. Then I went ahead and multiplied row 2 by negative 7, added it to row 1, and that was our new row 1. Then I went ahead and multiplied row 3 by negative 1, and that gave us our new row 3. Then I went ahead and multiplied row 3 by 7/3, added it to row 2, and that became our new row 2. And finally, we went ahead and multiply row 3 by -1/3, added it to row 1, and that became our new row 1. The augmented matrix then turned out to be 1, 0, 0, -7, 0, 1, 0, 4, 0, 0, 1, 2. Therefore, the solution here will be that x1 is equal to -7, the second variable is equal to 4, and the third variable is equal to 2. But notice that I'm showing my steps of how I got there, even though I may not necessarily be showing, in the video. Okay. Number 11 is something similar to number 10. Okay. And notice that we only have 2 equations, but 3 unknowns. Something tells me that this is very likely to not have a unique solution. So here we have 4, -3, -5, 22, 1, -2, 0, 8. So if it says to solve by Gaussian-Jordan elimination, we need to have a matrix in row reduced echelon form. So I guess what I'm saying here is 0 here. So a 1 in the first column, a 0 right underneath it, a 1 in the second row, second column with a 0 right above it. And then here, this is going to be, I'm just going to call it maybe some number A, some number B, whatever that turns out to be. And then here, maybe I'm going to call it N and M and N. Okay, so that's the goal here. Okay, so the idea is to take this augmented matrix, write it, transform it into row reduced echelon form, and then we'll pick out what the answers might be then. So let's see. Well, let's go ahead and go through those steps. I'll write it out, and then I'll show you guys what the steps will be. All right, so the steps that we took to get there were the following. Let's see. So row 1, swap with row 2, -4 times row 1 added to row 2, that's our new row 2. Then we went ahead and did 1/5 times row 2, that is our new row 2. Then finally we took 2 times row 2 added to row 1, and that becomes our new row 1. So therefore, this augmented matrix in row reduced echelon form is 1, 0, -2, vertical bar, 4, 0, 1, -1, -2. Okay, so when we write this in equation form, we then can say, well, this is x1 minus 2x3 is equal to 4, and x2 minus 1x3 is equal to -2. Notice, let me highlight, notice that the first equation and the second equation both involve this are in half x3. So we could say something like this. X1, let's see, where could I write? Maybe here. X1 is equal to 2 times. So if we move it to the other side, it becomes a positive. Okay, so it looks like that. And then the second variable is equal to, again, if we move this term to the other side, it becomes positive. So it becomes 1x3 minus 2. Okay, so I'm not really sure what they use in my MATLAB, but maybe they want to use the letter K. And so just make sure that you read what my MATLAB wants to do, or look at the, let's look at real quick at what the solution says. So let's see, what does it want? So okay, so look, it wants it in terms of t. So make sure that in this case, okay, so it wants it in terms of t. Okay, come on, come up, come up, come up. All right, so in this case, it says to let x3 equal to t. So therefore x1 is equal to 2t plus 4, while x2 is equal to 1t minus 2, okay? So just be careful with my MATLAB there. All right, let's move on to another example. All right, in number 12, we have, says use Gauss-Jordan elimination to solve the following system and then determine whether it has a unique solution, no solution, or infinite many solutions. So here's the augmented matrix, and after performing the following row operations, negative row 1 times plus row 2, that's our new row 2, negative 3 times row 1 plus row 3, that's our new row 3. And then after performing the following row operations, row 2 plus row 3, that's our new row 3. It turns out that this augmented matrix now looks like this. 1, 1, negative 1, 8, 0, 2, 4, negative 2. And then check the last line out. 0, 0, 0, negative 21. So what happened is that in this case, actually, well, it doesn't matter what these numbers are. I might have made a mistake here. But what happens is that we have a row of zeros that equals to negative 21. So here is 0 equaling some number. And so therefore, this will be false. And therefore, this will have no solution. This example will have no solution. All right, moving on to 13. Hopefully we're out of matrices and we can focus on something a little bit easier now. Find the difference. So this is a 2 by 2. B is also a 2 by 2 matrix. So therefore the difference is defined. And so A I'm sorry, not A minus B, is B minus A. So, okay, we have B minus A is equal to negative 1 minus 1. So it's going to be the difference of the corresponding entry. So negative 1 minus 1, 5 minus 1, 9 minus 3, and negative 9 minus 9. And so after cleaning this up, we get negative 2, we get 4, 6, negative 18. Okay, so in this particular example, number 14, we're trying to multiply the matrix, I'm going to call it matrix A, by some scalar. So in this case, what we need to do is multiply each one of these entries by, in this case, 8. So each one of these entries will be multiplied by 8. All right, so we have negative 80, 80, 40, negative 40, negative, in this case, what is that? 72. I want to say, that will be positive 8. And then here we have, in this case, what is it? That will be 56. And once again, 56. All right. That's the end of example number 14. Okay, so here we go with number 15. Oh, what's going on here? So find the product of matrix A times matrix C. Matrix A is a 2 by 3 matrix. Matrix C is a 3 by 3. So let's see if this product is defined. So we have 2 by 3 multiplying it with a 3 by 3. So therefore, because the inner numbers are the same, therefore, this product will be defined, and the product will be of size 2 by 3. So AC is going to be a 2 by 3 matrix. So I'm just going to work out one of the rows, okay, times one of the columns so that we can see how this is done. And then I probably will rely on the calculator to do this. So we're going to multiply this row times this column, and that will give us our very first entry. So that is going to be 4 times negative 3. So that will be, let me just write it out, 4 times negative 3 plus negative 5 times 2 plus 4 times negative 4. And so we have negative 12 minus 10 minus 16, and we get negative 12 minus 26, which is equal to negative 38. So the very first entry of the product A times C is going to be negative 38. Okay, but now I'm going to use the calculator and produce a solution. So let's hit pause. Okay, so going back to